The broadcast is now starting. All attendees are in listen-only mode.
Good day, everyone, and thank you for attending our introduction to scattering and the surface property, I should say, in TracePro. My name is Andrew Knight, Technical Sales Manager, and I have with me Dave Jacobson, who's our Senior Apps Engineer, who will be presenting. The format, as usual, will be an overview of scattering as it relates to TracePro's surface property function. It will last approximately 20 minutes, 30 minutes, and the presentation will be followed by a question and answer session, which you can ask via your GoToMeeting control panel. We'll address all the questions after the presentation, and with that, I'm going to give it over to Dave, and thanks again for joining us.
Okay, thank you, Andy. Again, good day to everyone. Good morning, good afternoon, depending on your time zone. And as Andy mentioned, the topic for today's webinar is going to be an introduction to scattering and the surface source property in TracePro. It's going to be kind of a basic webinar. We're not going to get too heavy in the math. I'm going to try to keep it as simple as possible. Just as a reminder, we've had recent updates on both TracePro and Oslo. So TracePro 7.0.2 and Oslo 6.5.2 are now available for download from our website. So we encourage users with current maintenance and support agreements to update to the latest versions of TracePro and Oslo. So in today's webinar, we're going to take a look at what scattering is and how it's measured. We're going to talk about briefly what is BSDF, BRDF, and BTDF. You see the terms mentioned quite a bit in TracePro. So what do they mean and how do they apply to your TracePro model? We'll try to give you an understanding of some of the different scatter models that are available in each version of TracePro. We'll find out how to use the scattering data that you may have, measured scattering data, to create a surface property in TracePro. And we'll look at a reflected and a transmitted scattering example for that. We'll also take a quick look at how changing surface properties can affect the results in your TracePro model. And then we'll wrap it up with the question and answer session. And as Andy mentioned, feel free to submit questions at any time during the webinar using the question box or the question panel on your GoToWebinar control panel. And again, we'll address all the questions at the end of the webinar. So, what is scattering? Quick look, actually got this definition from Wikipedia, and in this case it actually seems to be like a good one. So scattering is the general process where some forms of radiation, in the case of us with TracePro here, we're looking at light, and they are forced to deviate from a straight trajectory by one or more localized non-uniformities in the medium through which they pass, or in the case of surface scattering, the surface they interact with. In conventional use, this includes deviation of reflected radiation or light from the angle predicted by the law of reflection. Reflections that undergo scattering are often called diffuse reflections, and unscattered reflections are typically called specular or mirror-like reflections. So when you're working with scattering, especially in TracePro, you have two different types of scattering you'll typically see: surface scattering and bulk scattering. Surface scattering is scattering that occurs on the surface of the object. This could be reflected or transmitted. Some examples of this would be reflective coatings, mirror coatings, paints, diffusers, applied coatings, polished surfaces. Whereas bulk scattering is scattering that happens inside of an object. So this could be scattering inside of human tissue, inside of a fluid, inside of an opaque plastic or an opaque material. In today's session here, we're going to deal with surface scattering. So here's some couple quick screenshots showing some surface scattering. In this case, we have, turn my little pen on here. We have reflected scattering here. Our incident beam is coming in along here. We have the specular portion of the beam. And then we also have, in this case, the blue rays here in TracePro are representing the scattered light. And if you remember your default settings in TracePro, the colors of the rays relate to the flux. So red rays are the highest flux. Then when they drop down below 66%, they're green. When they drop below 33%, they're blue. So in this case, we can see we have some high flux rays specularly scattered and some lower flux rays here in the scattered direction. In this case, we have a transmitted scattering. We have a diffuser surface applied to the bottom surface of this object. So we have our incident beam and then our scattered rays here coming out the other side. I mentioned we're not really going to look at bulk scattering today, but I did want to show an example of it. Here we have an incident beam on a piece of material. I think in this case I made this as a piece of tissue, and then it has a scattering property applied inside. So you can see the rays coming in, and then they're just scattered all around on the inside. So bulk scattering, separate topic, but today we're going to focus on surface scattering. So I guess you could say, in a perfect world, at least from a modeling point of view, it'd be great if everything was either perfectly specular or perfectly Lambertian. It'd make our models much simpler. We'd have, incidence, reflected angle equals incidence, or we scatter in a Lambertian manner. But obviously reality, it's somewhere in between. So let's take a look now. We've talked here briefly about what scatter is, but let's take a look at how do you measure scatter. Scatter is basically, it's the ratio of the incident beam to the scattered or the reflected beam. In this case here we have a drawing. We have our incident beam here, and we have light coming off here. Here's our scattering surface along the bottom here. And the way we'd measure scatter is we would actually measure around this reflected beam and record those values. So you have the DE is the incident irradiance, DL is the radiance scattered from the area, and then you have the incident direction and the scattered direction. So basically here, to measure BSDF, you illuminate an area, you measure the incident flux, so that's your flux on your surface, measure the scattered flux, calculate the solid angle subtended by the detector, and then you calculate DL, DE, and BSDF, with the BSDF reducing down to this equation here. As I mentioned, I don't want to get too heavy into math here, but these slides or this presentation will be archived on our website, so if you'd like to go back through it and work through some of the equations yourself, please feel free to do that. Here's an example of a scattering measurement system. In this case, it's the Cassie instrument from Schmidt Measurement Systems. We can see here's our sample. We have an incident light source here, the beam, the detector over here, and the sample can be rotated. This is actually a goniometer type arrangement here, where the sample can be rotated, the detector can be rotated around the sample in several axes. And then all that data is saved and used to calculate the BSDF for the material. Here's another option for measuring scatter. This is the ScatterMaster ScatterScope 3D. In this case, everything happens inside the box. It has a fixed incident angle. You place your sample up here on the measuring surface, and it records the value and generates a scatter measurement for you. So, as I mentioned, BSDF, BRDF, and BTDF. You'll see these terms when you start to define the properties in TracePro. So let's just take a quick look here and define what they actually mean. BSDF stands for bidirectional scatter distribution function, and this is the generic scattering term. So it could be either reflected or transmitted. It's kind of the catch-all term. BRDF is the bidirectional reflectance distribution function, and BTDF is the bidirectional transmission distribution function. So these are the two that we work with in TracePro when we're actually defining our surface properties, BRDF and BTDF. So we're defining reflected and transmitted scatter. And there's no reason a surface or an object couldn't have both reflected and transmitted scatter. So once again, here's the screen that we were just looking at a few minutes ago. Adding in the actual equation here, we're looking at the ratio of the scattered radiance versus the incident irradiance, and the equation that the BSDF reduces down to. Now, in TracePro, scatter is actually defined as BSDF as a function of beta minus beta naught as opposed to the angle. And where the beta minus beta naught comes from, it's actually the projection of these vectors down onto the plane. So we have our reflected, our specular beam here, and our scattered beam here. Project those values down onto the plane, and you can calculate your beta and beta naught. If you're working in the plane of incident, it reduces down to sine theta minus sine theta naught. And at normal incidence, it actually reduces down to sine of theta. Some more information on the ABG BSDF model that's used in TracePro. As we mentioned, beta and beta naught are the vectors from that Harvey-Shack BSDF model that was on the previous screen. In this model, the beta vector is a projection of the unit vector in the scattering direction onto the tangent plane, and beta naught vector is a projection of the unit vector in the specular direction. And then ABG, which are the values you actually wind up entering into TracePro, are fitting parameters. And then the next slide will show a graph of this data become a little clearer what we're discussing here. So in the ABG model, A determines the height of the curve, B determines the point where the curve transitions from flat to sloped, and G determines the slope of the curve. This type of scatter model implicitly assumes that the surface is isotropic, independent of incident direction, because the independent variable beta minus beta naught is independent of that incident direction. So again, for isotropic type scattering surfaces. Here's actually a plot of scatter data as a function of beta minus beta naught. We can see the curve here, and it comes down and then it rolls off as you get further off axis from the specular beam. Remember, these are all referenced to the specular beam. The A would be here, the height of the curve. B is the flat portion here where this roll-off occurs. And then G is the slope of this part here. So try and draw with this little pen. So different materials will have different curves here. But it's these curve fitting parameters, these ABG values, are what you'll typically enter into TracePro to define your scattering function. So some typical BSDFs for a polished surface, the G is going to vary from about 1.5 to 3.5, more typically in the 2 to 3 range. B is going to be small, 1 e to the minus 6 to 1 e to the minus 10. As I mentioned, these are polished, highly polished surfaces, so the light is going to be mostly concentrated in the specular beam. So just moving slightly off the specular, which is what B is defining, the scattering will drop off quite fast. For diffuse surfaces, if G is equal to 0, the BSDF is perfectly Lambertian, and baffle coatings can come close to this. If it's not Lambertian, B could be large, 0 to 1, and G is large, 2, 3, 4, 5, or 6 or more. So this means if we looked at this curve here, you're going to be able to go further off from the specular beam before you start to see a drop-off. So the surface is scattering more light as opposed to being a nice polished specular surface. So what does this mean? Excuse me. What does this mean for TracePro? Well, this is the information that TracePro uses to model scattering from a surface. So we have the same beam here. We have, in this case, we have the default mirror coding. If you go to the default catalog for surface properties, using the mirror coding, incident here, specular reflection here, and this one here, same material, same beam, but now we've changed our surface property to the diffuse white, which is also in the default catalog. So incident, and then the scatter is off in all these directions here. And if we actually open up the surface properties in TracePro to look at the data, we see all the possible the entries you can have for the material here, or the surface property. So we have absorption, specular reflection, specular transmission, BRDF. Here's our ABG values that we were just talking about, and this is where you would enter those in. This integrated BRDF, I'll look down here at the zoomed in version, that's the total integrated scatter. So this material here, this mirror property, has 5% absorption, just a hair under 95% specular reflection, and about 0.13% scattered reflection. So very close, not quite perfect mirror, but very close to it. A perfect mirror would have 0 absorption, 100% specular reflection, 0 transmission, and BRDF would be 0 for transmitted and reflected. If we look at the diffuse white property, and we can see very low absorption, 0.1%. We have 99% scattered light, and we have our values here. So this is a Lambertian type coding with the BRDF being 1. So let's talk briefly here about the scatter models that are available in TracePro. And these vary with the additions of TracePro. So in TracePro LC, you have the ABG model. So this is the one we've just been talking about. This would be good for isotropic surfaces. So meaning that if you rotated the surface around, the scatter is not going to change. So a lot of like diffuse coatings, reflective coatings could be modeled in this way. So if the orientation of your sample does not affect the scattering, you can use the ABG model. Stepping up to TracePro Standard and Expert, you've got, it also has the ABG, but you also have elliptical ABG, elliptical Gaussian, table BSDF, and asymmetric table BSDF. These last 4 previously were in TracePro Expert. They've now been added to TracePro Standard. So if you're still working with older versions of TracePro and you need these scattering properties, they're now available in the Standard Edition. You don't necessarily have to be at Expert. So this could be a good reason if you're not at version 7.0 to upgrade to version 7.0. And then a full explanation of each of these scatter models is available in the TracePro user manual starting on page 7.15. If you want to find the manual in TracePro, you can just go to Help and then TracePro User Manual, and it'll give you a link to the website where you can download a copy of the manual. So taking a quick look at some of these surface property editors here, we can see here's the ABG model. We have absorption, specular reflection, specular transmission, BRDF terms for A, B, and G, and BTDF. So reflected terms here, transmitted terms here. And all of these can vary as a function of temperature, wavelength, and incident angle. So if you have a material that the scattering varies as a function of incident angle or as a function of wavelength, you can add those definitions here. If you have the measured data, fill out this property. You can add in different lines using the add and delete, add data points here on the side. If we look at the elliptical ABG model, very similar, but now we have X and Y terms for the A, B, and G. So you can define different values for the X-axis and the Y-axis, and then TracePro will interpolate in an elliptical manner between those two values. So this can let you model something that is not necessarily isotropic or not rotationally symmetric as far as its scatter. Table BSDF, you're now entering, you notice there's no longer ABG values here. You're actually explicitly entering the BRDF and BTDF values as a function of the beta value, so the scatter beta, beta minus beta naught value. So this you'd actually build this up in a tabular format. You'd have to enter in one line at a time for each scatter beta and then add the BRDF, BTDF. And then stepping up one level from that is the asymmetric table, BSDF, where once again you're defining your scatter data, but you also have an option of a scatter azimuth. So for non-rotationally symmetric scatter models, you can define them this way. And what might be something like this, if you had a polished surface or a machined surface that still had machine marks in it, or a grading, a reflection grading, where depending on the orientation of it, the scattering is going to be different. That's the type of thing you could model using the asymmetric table BSDF. And in some cases, if you have data that you receive from a manufacturer that has measured the scatter, it may come in this format because it may be an isotropic scattering, so uniform scattering depending on rotation angle, but just by variations in the measurement system, the data could vary slightly, so it may actually be best fit using the asymmetric table. And again, standard and expert now for these as of TracePro 7.0. So let's walk through here. If you actually want to make a surface property, you have some measured data you want to work with now, and you actually want to make the property for TracePro. We're going to look at a reflected example and a transmitted example here. So this is a screenshot from the BSDF converter utility that is in TracePro. As of TracePro 7.0, there's a new menu item called Utilities. One of the options here in that Utilities menu is the BSDF converter utility. And this lets you read scatter data, and it'll convert it to the format that TracePro can use. So we're looking at data from CASI, from the CSV files, from the scatter scope, Alanod data. There's a few other options there as well. And sometimes that data is not always in the beta minus beta naught format that TracePro uses. So this utility will allow you to convert that from scatter versus angle to scatter versus beta. And you can fit the ABG curve here. So here's actually the curve fit to this data. It gives the values, the ABG values here. And then what we're going to take and we're actually going to make a property with this. In the way you make properties with TracePro, if you haven't had the chance to do it yet, if you go to Define, Edit Property Data, in this case we want to do a surface property, and then that brings up the surface property editor. We can pick a catalog where we want to save the material, or we can define a new catalog. You click Add Property, give the property a name, and then that'll bring up here where you can define your scatter model. It's covered up here now, but you can define a temperature and a wavelength that you want to work at as well. So in this case, we're going to do an ABG model. we now have the surface property editor open for editing here. We can enter in this case, I defined the absorption as being about 5%. I entered in the ABG values I got from the converter utility, so 0.030597, 0.042433, and 2.030241. And then what I do is we have an option here called solve for. In this case, I solved for the reflectance. So in this case, I solved for this specular reflection value. Excuse me. So in TracePro, the one thing you have to remember is that the property must conserve energy. So absorption plus reflection, specular reflection plus specular transmission plus scattered reflection plus scattered transmission have to equal 1. And if we add up this absorption, specular reflection, and integrated BRDF, that'll work out to 1. And this little solve for button here allows to let the program do the calculation for you. So we took that property, I applied it to this first surface of this object here. I have my incident beam, and then I looked at a candela plot here. So the candela plot's actually oriented along this axis here, along the y-axis. But you can see the scatter here. It's not perfectly specular. It has a certain amount of divergence to it. If we could look in here even closer, we'd see probably a little bit of a lobe from this scattering here. So very easy to create a surface property when you have that that data and you have that measured. Take a look at now a transmitted example. So this would be a diffuser. In this case here, I was looking for a transmissive diffuser with a 30-degree Gaussian distribution. And this dotted line here in this graph is the 30-degree Gaussian distribution that I was aiming for. This blue curve is actually the ABG curve fitted to that data with these values. A and B is equal to 0.1, G is 2.6. And this is actually a little spreadsheet we work with sometimes. I'll see if I can actually get this posted on the website so you can download it and use it. But so we fitted this curve, and this was a manual fitting, just playing with these values. There is a little bit of error here at the tail end of the curve, but for the most part it fits pretty well. So again, I open up my surface property editor. In this case, I gave it a new name, 30-degree diffuser. I set absorption again to about 5%. But this time now we're working with BTDF. So this is a transmitted scatter. And we enter in the values, the 0.1, the 0.1, the 0.26. And we do a solve for BTDF. So I'm solving for this value here. You can see it actually changed the A value slightly to get the fit to the 0.95, but it's very close to what the value we'd entered. And once again, property must conserve energy, so all the values have to add up to 1. If we look at that applied to a surface, in this case it's applied to this second surface here. We have the light going through the object and then being diffused by this. And here's our roughly 30-degree Gaussian diffuser. Here's the 30-degree line right here. I'll just draw that in. So we're fitting that curve quite well. So I want to wrap up here. I just want to take a quick look and just see the effects of changing the surface property on a model in TracePro, and some of the effects you'll see and why you may want to do that, and probably why we can't always go and say everything's a perfect mirror or a perfect diffuser. So for this model, simple parabolic reflector with a small cylindrical source inside here, and I have a target out here where I'm going to collect my rays. And I made this model with four different properties. I did the perfect mirror. Remember, I mentioned the perfect mirror that has specular reflection is 1, absorption is 0, specular transmission is 0, and there's no scatter. So angle of incidence equals angle of reflection. Everything is in the specular direction. Alinod Miro 2 and Alinod Miro 8. Alinod is a company that makes reflective sheet material. Probably some of the most common applications you'd see would be overhead fluorescent lighting, the inserts, the reflective inserts. And Miro 2 and Miro 8 are just different surface finishes. And then for the heck of it, I threw diffuse white on the surface as well. And you can see here, here's my target. I just set it to be partially transmissive, or the view of it to be partially transmission, so you can actually see some of the rays hitting it. We can see perfect mirror, and we look at Alinod 2. Beam doesn't look that different here, but we start to see a lot of blue rays, so we're seeing some scattered light because it's not a perfect mirror property. More so of the lower flux rays in the Miro 8. And then the diffuse white is just scattered all over the target. I'm also in this case using the ray sorting feature in TracePro, so only showing rays that are hitting this target to kind of simplify the picture down a little bit. And here's the properties. I just cut out the relevant parts from the property editor. Perfect mirror, 0, 1, 0. The Miro 2. This has 90% specular, 5% scattered light. The Miro 8, 28% specular, 66% scattered. So a little more diffuse or scattering type surface. The diffuse white, here again, it's all scattered, 99% scattered. If we look at the irradiance maps here, one thing you can look, there's not, with a quick look, it's just the pictures, they don't look that different between the perfect mirror, the Miro 2, the Miro 8. But if we look at these values here for the peak irradiance, we're at up to 140. Here we're at about 125. Here we're down to 40. And obviously the diffuse white is a much different picture. So we're seeing less light at the center of the target here when we drop down to the more scattering, less specular material. Looking at the ISO candela plots, so we're looking at the angular distribution on that target. Again, in this case, it's hard to see much of a difference, but I changed and I zoomed in a little bit on those. So with a quick look, there's not a lot of difference here, but we start looking at the candela values. Here we're at 122 watts per steradian. Here we're at about 438, and here it's about 394. So as we add scattering to the object or to the surface, we're seeing less light, a less intense beam, and we're starting to see the light be scattered out a little more, so a little more diffuse. So with that, I'm going to say thank you. Hopefully you found this some informative information. We are planning for an upcoming webinar to go into more detail about the BSDF converter utility that I briefly mentioned, as well as a demonstration of the ScatterScope 3D, the picture I showed you earlier. We're going to show a demonstration of that as well. So with that, I'm actually going to open it up to questions and answers, and I'm going to bring Andy back into the picture here.
Thanks, Dave. Nice job. So it looks like we have quite a few questions already. They're popping up all over the place. And the first one is, does TracePro support anisotropic, reflective, or transmissive surfaces?
Yes, you'd have to be using the asymmetric, most likely the asymmetric BSDF table for that. So you can get you can define it as an azimuth angle there.
Excellent. And then second question is somewhat related. Where can we obtain a list of available BSDFs that are accurately measured already?
I would look to the manufacturers of the material. A company like Alanod does have downloads of the BSDF data. Actually, I believe they listed under BRDF data. I think you just have to sign up with your email address on their website. But I would be looking towards your manufacturers. We do have, some scatter models in TracePro, some catalogs from Alanod, Alcoa, Almico. So there is some data in TracePro as well, but a lot of these materials vary enough that it's sometimes necessary to get measurements made. And if you're looking to get measurements made, drop us a note. We can point you into the right direction to some different companies that can make that type of measurement.
Okay. Next question. How constraining are the BSDF models? Can they capture the richness of surfaces with complex topography? And also, can TracePro use real-world data from the scatterscope or CASI?
Well, I think capturing the richness, the surface complexity is going to depend on the on the measurement. How detailed of a measurement do you make? The constraints, the ABG model has the constraint of that, it wants to fit to that ABG, that curve, but then you have the table BSDF properties where you can explicitly define the values. So the table BSDF and the asymmetric table BSDF would be able to define more complex surfaces. And can TracePro use real-world data from Scatterscope or CASI? Yes. We can read both of those formats right in using that BSDF converter utility and generate properties for TracePro. The converter utility actually has the option. I didn't cover it here because we're going to dedicate a little more time in the next webinar to that. But you can save models either as ABG or as table BSDF. So you'd be able to capture a little more of that detail using that table BSDF.
Okay. Next question. How much do you charge to measure scattering data of material samples?
Well, right now we don't measure scattering ourselves. We generally work with other companies to get that measured. And what I would say in that case, I'll just go here is give us a call or drop either Andy or myself a note, or send an email, probably to sales@lambdares.com, and we can put you in touch with the right people to get that done.
Let's see. Why not add a native Gaussian scatter model as opposed to trying to fit an ABG model?
We can certainly take that as a feature request. I've mentioned that in the past, so that might be something I think we could look at doing to simplify that down. So I will add that in as a feature request for TracePro.
Okay, and is there any way to use TracePro for surface topography design?
I guess going in the opposite direction so that you actually start with a target.
Good question.
Not that I know of. I mean, it might be possible to write a macro that could vary some of the surface properties, but we'd really have to take a look at that. It's not something we've done at this point, but it could possibly, but I don't think it would be an easy task.
I would agree.
Yeah.
Well, this is an easy question. Will these slides be available on your website? The answer is yes. They will be posted probably by tomorrow under the webinar section.
Yes.
Okay, so let's see. Where do you get BSDF data and in which formats? Any standards out there?
Well, two of the options would be, as we mentioned there, Scattermaster or Schmidt Measurement Systems. They do scatter measurements. They can do it, or you can buy the equipment from them. I'm sure Schmidt would be happy to sell you a Cassie to do your own measurements. But also, yeah, there are standards. Each company sort of has their own file format. That's what we try to work with the BSDF converter, is to be able to read those different file formats. So yeah, the best bet would be to talk to those companies, and then we can work with you on that as well.
Okay. The next question is, the last time I used the Surface Property Editor, the plot function didn't really do what I expected. Can you show me how to use it?
I'm actually not set up to do a live demo right now, but why don't we take down, we can, I don't know if it'll actually show the scattering function like that, but we'll take down the email address and get in touch with them.
Yeah.
Yeah, we can see who that is here.
Okay, the next question is, how about if you have an absorbing emitting medium as fluorescent dye doped in PMMA?
Then what you would probably be looking at doing is, first of all, TracePro has fluorescent capabilities, so you could get that.
TracePro Expert does.
TracePro Expert has. So now you're moving into more bulk scattering and fluorescence, as opposed to the surface scattering that we were mainly focusing on here. But certainly it is something that that can be done in TracePro. I'd look at TracePro Expert for the fluorescent modeling capability, and you can also then define bulk scattering and bulk absorption for the material property. But those are definitely TracePro Expert type features, and
correct,
and probably could possibly some topics for another webinar.
True. Let's see, the next question is, do you have a library of light sources in TracePro, or do we need to get to the manufacturer to get them modeled? How does this process work?
Well, it's getting a little off topic here, but I can touch on it. There is a library of lamps that you can download from our website. It's under the TracePro technical support section in libraries. It has a lot of filament and short arc or archetype lamps. Also, the surface source properties in TracePro has several LED catalogs already preloaded, from Cree-X lamp, a lot of the Luxian LEDs, and a lot of the Osram LEDs. So they'd be under the surface source properties. And also take a look at the surface source property generator utility that would allow you to create a surface source property using an LED data sheet. I would suggest there as well taking a look at the webinar we presented back in January, which did a demonstration of the surface source property generator utility. So go to our website and then to the webinar section and look up the January webinar. It'll show you how you can use that property to generate your light sources.
Good. The next question is, what is the benefit of having this BSDF data to the radiance or luminance analysis? Are we getting a close, sounds like a real, real world result? Yeah.
Yes, well, that goes back to one of the slides I mentioned, where I guess in a perfect world, at least for those of us doing modeling, everything would be perfectly specular or perfectly diffusing. But really, reality of the real world is somewhere in between. So this allows you to add the scattering properties that your models or that your objects really have. I mean, I'm looking here. I have my computer in front of me. There's glossy plastic on it. The desk is a more diffuse type reflectivity. So if I was trying to model real world situations, it really does benefit you to have the most accurate scatter models you can get. And sometimes that means sending samples out to labs to get them measured, because the better your data, the better your model is going to be. So yes, this does let you get closer to what your eye would see or what your real-world detector would measure.
Great. Next question. What is the advantage of using the ABG model over the table BSDF?
Simpler to define. It's only the three terms, and you're fitting a curve as opposed to explicitly defining every point. Also, if you're working in TracePro LC, the ABG model is the only option. So I would think it comes down to some simplicity, and may even probably be some speed in the ray trace as well. The surface is probably a little quicker to model.
Right, right. The next question is, can you search among BSDFs to find the optimal one for a given light application?
No, not natively. That you would probably, I could see writing a macro to change a surface property to do something like that and save the results, or a quote unquote manual optimization, going through some of the different catalogs and doing it that way.
Gotcha.
Yeah.
So the next question is, are the scatter scopes capable of bulk scattering measurements? And then BTDF, bulk scattering plays a role there as well?
Yes. As far as I know, those scatter scopes do not measure bulk scattering. So that's the terms for bulk scattering. You'd be measuring anisotropy and scattering coefficients. I don't believe they do, but we could check on that and see if we can find it. And you're correct too. If you're doing a transmission measurement, bulk scattering may have a role if you don't have a perfectly clear glass or plastic. So that's another level of complexity that you can add, or detail that you can add into your model. So that's if you're doing transmission type measurements. But I guess the other way to look at that is, if you're doing a scatter measurement and you're actually measuring the results, so you're measuring a complete system. So the bulk scatter is actually inside the material, and it's sort of being measured by the scatter meter, or the scatterometer. So the effects of it are being measured. So if you were to treat that then as a surface property, you might be able to get fairly close. But what you'd lose is the ability for, as you increase or decrease the thickness of the material, the effect that would have. You'd actually have to have discrete models for every possible thickness of the material.
Yeah. The next question is, some data sheets specify gloss, haze, or some similar sort of generic term. Do you have a tool to convert such data to the ABG model?
No, we don't. I've looked at this myself, and I think it's something I need to dig into a little bit more as well. The problem with some of these measurements is like gloss and haze is they're really defined at one angle. They may use a relatively large detector, so they don't give you the level of detail to really give you the capability of defining that BSDF, or from a modeling sense of view. I have had that question from other people in the past, so I think it's something I want to take a little more look at and see if there's any way we can get some results from there. So stay tuned. If we do get something there, we'll certainly be happy to let you know.
Okay. Any rule of thumb on when a surface scattering does the job? For example, a diffuser, and when bulk scattering is necessary to include?
I don't really have a rule of thumb, I guess. It could relate back to the answer I was giving a few minutes ago, where if you've measured an object for transmitted scatter, the bulk scatter is sort of encompassed in that measurement as well, because you're measuring the effect of basically the output of that diffuser. But it's, what may come down to is some ways, how do you separate surface scatter from bulk scatter on a diffuser? And I'm not quite sure how to do that myself right now. But no, unfortunately, I don't have a rule of thumb. I would say try to make some comparisons to some actual measurements and see what you may have to do there.
Okay. Next question. If a surface with a known RMS roughness, are we able to calculate the ABG model from that?
You can, if that RMS roughness is very, very small, basically down around the wavelength of light. The problem with trying to do it with a larger scale is that RMS is an average measurement, root mean square, and it doesn't tell you about really the profile of the scattering. So if you have, say if you had a grating where you had flat plane or prismatic type structure versus something with more of a sinusoidal type structure, they may have a similar or the same RMS roughness, but really their scattering would be quite different because you don't have that local that local surface normal, that local angle, and how that slope is defined. So really there isn't an easy way to do that. It's a case of probably having to get it measured.
Okay. The question next is, can you define custom BSDF parameters with TracePro to quantify, for example, isotropy or diffusiveness?
As far as parameter, I mean, you can define your own models. You are limited to the, like if you're using the table BSDF or asymmetric table BSDF, you're defining the BSDF value as a function of the scatter of the angle, the beta minus beta naught. So you can use that to define the isotropy of the diffuseness that way. I think if that's the way I'm understanding the question.
Okay. And then, can one increase the angular resolution with TracePro and input scatterscope 3D data to handle differences in near specular surfaces?
Yes, because I mean originally the ABG model was originally set up for measuring very small, very micro roughness on like telescope optics. So it's actually very useful for scattering near the specular. So I don't know off the top of my head the angular resolution on the scatter scope, but I know the angular resolution on the Cassie instrument is quite small. So you could check out Schmidt measurement and see the angular resolution there to be able to handle roughness near the specular. And then you could define that in TracePro as well. You could set up your angular values to be have a high enough resolution.
Okay. And then I think this is correct. What is the acceptable surface RA range for TracePro?
I guess I don't know what RA is standing for there.
I didn't either, so I was hoping you did.
If the asker can just clarify that, we can try and surface roughness. Well, that's what happens there. It's the surface property is best, with roughnesses that are on smaller scales. If you get to large scale roughness, and when I start talking large scale, features that can be, getting up, millimeter in size, or people that are in the lighting industry, the hammered reflector surfaces, the dimpled type surfaces. Those are usually actually best measured, modeled as a 3D model, right? You would want to, because what actually happens at the micro level, it's the surface roughness is actually can be very smooth, so it can be a very specular surface, but then the geometric structure is actually what's giving it the scatter. So because if you think of the instruments, for the most part, are using a laser source that's rather small in diameter to measure the roughness, it can give you a feel of where you have to switch to a geometric type modeling versus a surface roughness.
So there's a point where you probably prefer to physically model
exactly
surface versus just trying to put an equation in for scatter.
Right, and I don't have an exact answer for when that switchover would happen.
Yeah.
But,
wow, good questions today, gentlemen and ladies, if there's any out there.
As we're winding down here, I just want to put up a screen for some additional reading. Excuse me. The TracePro user manual has an excellent technical section on the scatter models that are in TracePro, and sort of one of the main books on this topic is Optical Scattering Measurement and Analysis by John Stover, which you can get from the SPIE Engineering Press.
Okay, looks like a couple more popped up.
I can grab this. Is the manual available for download online? Yes, it's in the releases section of the TracePro technical support portion of the web page. So it is actually in a section that you will need to be a current maintenance and support customer to be able to get to, but you can download it from the website.
It is there.
Yeah. If you can't find it, drop us a note at sales, and we can point you in the right direction.
So I have one last question here. I noticed that there are quite a few challenging and interesting questions raised and answered in this session. Will these questions be recorded for review? And the answer is yes. We're recording this whole session, and we're going to be putting it on the website probably by tomorrow. Yeah. So you can come back and review it at any time.
Yeah. Okay. Well, with that, I think we should wrap this up. We're at, again, for any additional information, please feel free to contact us here, Lambda Research Corporation. We're in Littleton, Mass. 978-486-0766. And our webpage is at www.lambdares.com. And we said feel free, questions, sales@lambdares.com, and we'll be happy to work with you on any of those things. But, so again, from my part, thank you to everyone for attending this morning, and I hope everyone has a good holiday season.
And I will concur with that as well. I hope everybody learned something today, and thank you very much for attending again. Happy holidays, everybody.